Okay, question 6 says find an analytic expression for this one here, and then the perfect cube formula may help. So I'm gonna do that one. I have to move it out of here. So this one said tangent cube a plus 1. I actually have to look at it. And this was question 6 divided by tangent a plus 1. And then I use that perfect cube, so in the numerator, sorry about that bad fraction line, drop that again, there we go, that looks much better. Okay, so that one, therefore, again, when you look at the perfect cube formula, it's going to look like this. Tangent squared minus tangent plus 1 parentheses divided by tangent a plus 1. And then, of course, that divides with that. And now I'm going to look at the answers. And that answer that I just came up with indeed matches one of the answers, the last one there, tangent squared minus tangent a plus 1. Okay. Question 7 says write an expression as a single trigonometric function. So I have a cosine 8x cosine x minus sine 8x sine x. For that one, I'm looking at the right hand side, where I have a cosine times cosine minus sine times sine, and therefore I'm going to have cosine plus for that minus. So therefore it's the second one. I don't even need to write this down. This one here is 8x, this one is x, and the original formula says a minus, which then according to this identity formula turns into plus. So it's 8x plus x cosine of 9x, and the first one is correct. Okay, question 8. So if tangent a plus b equals 9 and tangent b equals 1 over 73, find tangent a. Okay, there are several ways of doing it. There's the crude way of plugging it into the calculator and see what works. But the proper way is to do the algebra. And here the idea to get is, where do I actually start? They give tangent b and then they say something about tangent a plus b. Well, that means there must be some kind of identity that I use, and in fact that was in the last problem. Right there it is. Tangent a plus b equals this stuff here. And one of these here I'm going to write down as tangent b, 1 over 73, and the left hand side I will eventually write down as 9. So that's what I'm going to do. Again, I need to push out of the way so I have space. So question 8, where I'm going to start out with tangent a plus b equals fraction bar, and then I have tangent a plus tangent b divided by 1 minus, look carefully at the identity, tangent a times tangent b. And now I go in there and use what is already given. The left hand side is supposed to be 9, and on the right hand side, let's see, there's a pretty thick fraction bar, but I'll use it rather than hand drawing it. I'm going to have a tangent a plus 1 over 73 minus 1 minus tangent a times 1 over 73. Okay, let's see, there are several ways of doing it. One would be algebraic, the other one would be just trying something for tangent a, see what works. But first I'm gonna get rid of that 73 out of these denominators here, so I just multiply the top the numerator here with 73 and this denominator with 73, and of course I didn't change anything in the value when I do that, so I don't have to do anything on the left hand side. Plus 1, and this one here is 73 minus tangent A, and my 9 got a little bit too small. There we go, looks a little better. Okay, well, at this point I could solve for tangent A. Takes me a little bit of algebra, or I could look at what kind of answers I have. So tangent A could be 8, 9, 10, 11, or 12. I don't know if that's gonna really help me. I just do the algebra. Okay, that's kind of going to take a moment here. 9 times 73 minus tangent A. That's of course something when you start a problem that is hard to see which problem turns out to be really easy and which other problem turns out to be, well, taking a while. In this case, this one here will take a while. Let's see what we get. 9 times 73 is 657, if I'm not mistaken, minus 73 tangent A. Oops, that's not true. Minus 9 tangent A equals 73 tangent A plus 1. Actually, that's not too bad. Subtract 1 from this one here, so that's 656 equals, and then 73 minus plus 9. 73 plus 9 is 82 tangent A, and then tangent A, divide 82 into 656, which is 8. So the correct answer is 8. Okay, and the next one says, okay, I was interrupted for just a moment. Okay, so I have cosine 2x, and I'm supposed to express it as cosine plus x, and then using a formula for the cosine of a sum. That formula for the cosine of a sum would be this one right here, so I'm going to use that in a moment. Cosine times cosine minus sine times sine. Remember that it's at a plus in, for the problem at hand. Okay, let's see, there it is. So this is question 9, and I'm supposed to express cosine 2x as cosine x plus x, and then I'm supposed to use a sum. So I'm going to come up with cosine x times cosine x. This is the sum formula that is given in the test, minus sine x times sine x, and that is of course cosine squared x minus sine squared x. Notice this is not the Pythagorean, okay, because there's a minus. Pythagorean has a plus. And then I excuse me, then I look at the correct answers, and indeed that is this answer. It's the correct one. And actually, essentially what I did here is the problem told me to find write a formula for this one. Essentially what I did here is I found an identity. Cosine 2x is the same as cosine squared minus sine squared. So with a little bit of a hint, so that's what I did. Okay, question 10.